Okay, now the most crucial part that we really need to get out of the way. This is very important. So this is when you have a function embedded within a function. They're saying express this as a composition of two functions. The way you work this, you would write this as f of g of x, and you would always start from the inside out. That is, you choose g of x first, and the way we're going to do this, we would choose g of x to be the inside of a radical, the inside of a power function, sometimes the denominator of a fraction, right? The argument of a trig function, depending on what it is. So if I look at this as the cosine of x squared, if I let g of x equal cosine of x, then f must be what? What do you substitute cosine of x in to get the cosine of x squared? Isn't it x squared? And that's how it works. So that's pretty much what you have to do. You have to say this is f composite g. If g of x is cosine of x and f of x is, so if g of x is cosine of x and f of x is x squared, then f composite g would be f of g of x. That would be f g of x is a cosine of x. Take this and square it. The other way wouldn't work. It's really important to get this out of the way. The idea might seem something easy and simple. Well, it is. There is one exception, however, I will not accept. You cannot let f or g equal just x. You can't. Or the whole thing. That's not allowed. The idea is we're trying to break this, decompose this. If you let one of those be x and the second one be the whole thing, that's counterproductive. That's not what we want. You're not allowed to do that. So on a test, when I ask for that, not if I ask for that, you have to choose anything other than letting one of them be x. So I get to 46, the same idea. I start with g of x. If I let g of x equal, in this case, the easiest way, the inside of a power function. I could think of this as, this is raised to the 1/3. If I let g equal x over 1 plus x, then f of x will be, what do you do to this to get the cube root of it? Well, just take the cube root of whatever that is. It's pretty much taking this and substituting that in there, and that will work. For what we need, that's more than sufficient. And here, what would you let g of x equal? Well, if I let g of x equal, and let's see how this works. If I let g of x equal, how about a tangent of t? And notice now what I have to let f equal. What do you replace? Where do you replace tangent of t in to get this? Well, an x, a 1, and a plus x. If you replace tan of x by those x's, you will get that. And I have a bonus problem for you. I know you love bonus problems. On the last problems, well, couple problems, I want to start with f composite g composite h. This doesn't come up as much, but it does come up. Start with h. I should let h equal the insidemost function. What do you think? Remember, I don't want to do this in 2. I want to do it in 3 stages. Otherwise, I would have let h equal all of that. But instead, if I let h equal just the absolute value, do you notice that this will be the 8th root of 2 plus x? And now, in order, if I let g, the secondmost function, equal, and can you guess what? 2 plus x. Now I'm looking at f to be the 8th root of x. And let's see. If I take g embedded, h embedded in g, now it's twice plus the absolute value of x. And if I take this and embed it, I will get back where I started. Something you should practice. Don't underestimate. Please do the homework. It's really important, especially when we get the chain rule. And these things come up. Either they give us a graph and you read the graph off, Or they give us a table and you read that. It's kind of like a puzzle to me. It's kind of fun. So if I look at A, part A says, what is f of g of 1? What's g of 1? This is x equal 1. It's one of those two. What do you think that is? G. There's g. Isn't that a 6? And this says f of 6. Well, now that I got x equals 6, there's x equals 6, and it's one of these two values. I want the f, and do you see what that is? And there it is. Kind of fun, I don't know, I think. Let me restart this. That's the beauty of using this. B, if I want g of f of 1. What is f of 1? X equal 1 is right there. It's one of those two values. What would that be? I want the f. I want the 3. And this is saying now, if x equals 3, if x equals a 3, it's one of those two values. Where's g? There's g, so that would be a 2. Yeah? Simple, no? Something you gotta adjust to because it's has a lot of applications. How about C? What is f of again, x equal 1? If I go to x equal 1, it's one of those two values. I want the f, that'll be a 3. And now this says, if x equal 3, there's x equal 3, it's one of those two values. I still want f, and that would be a 4. You could have a function callback itself. We have tons of applications for those. And if I go for D, I want g of, oh, I forgot to reset it. I want g of 1. If x equal 1, it's one of those two values. G is right there. That's a 6. And now this says, if x equal a 6, which value do you want? You want g again, and that would be a 3. Alright? If I go for this, part E, that says g of f of 3. If x equals a 3, it's one of those two values, and I want f. There's f. That would be a 4. And now if I go for x equal 4, it's one of those two values. Which one do I want? I want the g. There's g. So it has to be the 1. And if I go by the last problem, I want g, I want f of g of 6. So this restricts x to be 6. There's x equals 6. I want the g function. That's a 3. And this says, if x equals 3, there's x equals 3. I want the f function. There's the f function. So we're talking about a 4. Not a lot, but I couldn't fit them in the last video, but there it is. And there's the homework for this section.